In this video, you'll learn how covalent bonds form, why atoms share electrons, and how to represent these bonds using Lewis structures and real molecular examples like hydrogen, chlorine, methane, and ammonia with lone pairs. Atoms are driven to reach stable electron configurations similar to noble gases. This usually means having 8 electrons in the outer shell, called an octet, or 2 for very small atoms, a duplet. Unstable atoms will gain, lose, or share electrons in chemical reactions to reach this low energy, more stable arrangement. A covalent bond forms when two atoms, typically nonmetals, share one or more pairs of electrons. Instead of fully transferring electrons, they compromise by sharing them, allowing each atom to count the shared electrons toward its valence shell and achieve a stable duplet or octet configuration. Covalent bonding is favored when both atoms have relatively high ionization energy and high electron affinity. In other words, each atom holds tightly to its own electrons and also strongly attracts additional electrons, so sharing electrons between them becomes more energetically favorable than transferring them completely. Lewis structures represent valence electrons as dots around element symbols. To draw one, write the element symbol, determine the number of valence electrons from the group number, and place dots around the symbol. These dots show how atoms can share or pair electrons to form bonds and achieve stable configurations. In a hydrogen molecule, each hydrogen atom has one valence electron and needs one more to reach a stable duplet. The two atoms share a pair of electrons, forming a single covalent bond. Each hydrogen now effectively has two electrons in its valence shell, creating a stable H molecule. Each chlorine atom has 7 valence electrons and needs one more to complete an octet. Two chlorine atoms share a single pair of electrons, giving each access to 8 valence electrons. This single covalent bond holds the Cl molecule together while allowing both atoms to achieve stable octets. In methane, one carbon atom with 4 valence electrons bonds with 4 hydrogen atoms, each needing 1 electron. Carbon shares 1 electron with each hydrogen, forming 4 single covalent bonds. Carbon reaches an octet with 8 valence electrons, while every hydrogen attains a stable duplet in the CH molecule. Ammonia contains a nitrogen atom with 5 valence electrons bonded to 3 hydrogens. Nitrogen shares 3 electrons to form 3 single covalent bonds and keeps 2 electrons as a lone pair. The bonds give nitrogen an octet and each hydrogen a duplet, while the lone pair influences molecular shape and polarity. You've seen how atoms share electrons to reach stable duplets or octets, how Lewis structures depict these shared pairs, and how molecules like H, Cl, CH, and NH illustrate single bonds and lone pairs. Together, these ideas form the foundation of understanding covalent bonding in chemistry.